This is the second half review for Algebra 1A. We solved systems of linear equations, and there was three different types that we saw. The first type was intersecting lines with one solution. The next type we saw was parallel lines, and they had no points in common, so no solution. And the third type were coinciding infinitely many solutions. All the points on one were on the other. So this was the framework we kept in mind, whether we were solving by graphing, elimination, or substitution. Here we're going to solve by elimination. So we're going to add our equations together. Notice they're both, the like terms are lined up. The x terms are over each other, the y terms, and the constants. Negative 7x plus positive 7x is 0. It's eliminated. It's gone. 2y plus 3y is 5y. On the right side, 9 plus negative 4 is positive 5. So we have a one-step equation to solve. To get rid of multiplying by 5, divide by 5, y equals 1. Now to find x, we'll plug this 1 back in. You can go to either equation. I'll go to the top one. So we'll have negative 7x plus 2, instead of y, we'll put 1, equals 9. 2 times 1 is 2. And now we'll subtract 2 from each side. And so we have negative 7x equals positive 7. And finally, we'll divide by a negative 7. And so we have x equals negative 1. So our ordered pair, our solution is negative 1, 1. Also going to solve by elimination. We'll add our equations together. X are eliminated, y's are also eliminated, so we need to write down the 0. 12 plus negative 12 is 0. 0 equals 0, that's true, so think back to your three possibilities. It's going to be infinitely many solutions, or IMS. You can abbreviate as IMS. On this one, if we add them just like they are, nothing's eliminated. We would have 6x and negative 1y. So what we need to do is multiply our equations. We'll multiply the top one by 5 and the bottom by negative 1. So what I'm doing is making sure that the x's are eliminated. I'm taking that coefficient from the bottom equation, multiplying the top by it, and then multiplying the bottom one by the top coefficient on the x. But we're making sure that these are going to come out to be one positive, one negative. So in the top equation, 5 times x is 5x, 5 times y is 5y. On the right hand side, negative 9 times 5 is negative 45. For the second one, distributing in negative 1, we get negative 5x plus 2y equals negative 32. We'll add our equations together. X's are eliminated. And so we have 7y equal to negative 77. Now we'll divide both sides by 7. And so y is negative 11. We'll take this value, plug it back in. I'll go with the top equation. Top one was x plus y, so instead of y we can put negative 11 equal to negative 9. To get rid of minus 11, add 11, and we get positive 2. So x equals 2, y equals negative 11, so it's the ordered pair 2, negative 11. So these are intersecting lines, and the point they have in common is 2, negative 11. Alright, the sum of two numbers, sum means add, is 20. So we don't know what the numbers are, so we'll call one x, one y. So we have x plus y equals 20. Next, the difference of the numbers is 4. Difference means minus, so subtract x minus y equals 4. Now we're ready to add our equation together. 1x plus 1x is 2x. 1y plus negative 1y is 0, it's eliminated. 20 plus 4 is 24. To get rid of multiplying by 2, divide by 2, and so we get x equal to 12. So one of our numbers is 12, and we'll substitute in. We'll have 12 plus y equals 20. Subtract 12 from each side, and we get 8 for the other number. So our two numbers are 12 and 8. They add to get 20, they subtract to get 4. Graphing, we've got a slope of 2 over 1, y-intercept of -1, because y equals mx plus b, where m is the slope and b is the y-intercept. You can think of that b as your beginning point, so we're going to begin at -1, and then we'll go up 2 to the right 1. So we have the first line graphed. Now for the second one, slope of 1 over 1, y-intercept of 1. We want to think of slope as, we want to think of our slope as a fraction when we're graphing. So y-intercept 1, go up 1 to the right 1, and you can see where they intersect. Place where they intersect is your solution, so our solution on this one is 2, 3. 2 is the x value of that point, 3 is the y value of that point. X then y. Alright, on this one we have a slope of 5 over 1, y-intercept of -2. So plot a point at -2, and then go up 5 to the right 1. For the second one, we have a slope of 3 over 1. We don't see a number, a constant, so our y-intercept is 0. So put a point at 0, 0 at the origin, and then go up 3 to the right 1. You can also go down 3 to the left 1. And so we see a solution this time of 1, 3. Next we have a slope of -2 over 1, y-intercept of 3. Put a point at 3, go down 2 to the right 1. We'll connect those. Next we'll have a slope of -2 over 1, y-intercept of -1. Put a point at -1, go down 2 to the right 1. So you'll notice we have parallel lines, so there's going to be no solution. You may see that written as empty set. The solution set is empty. Here we have a slope of 1/2, y-intercept of -3. Put a point at -3, go up 1 to the right 2. Oops, I forgot to change this. This other one should be +2. So it should be x equals 2. Now when we graph this, we'll be able to see the intersection point. So find 2 on the x-axis. The reason we're looking at x-axis is because x is the only letter mentioned here. So draw your vertical line. X equal to a number is always vertical line, y equal to a number is always horizontal. And so we see a solution set at 2, -2. All right, we have a slope of -1/4, y-intercept of 3. So plot a point at 3, go down 1 to the right 4. You can also go up 1 to the left 4. Now this time, for inequalities, we have to decide if it's dashed or solid, and then also if it's going to be shaded above or below. This one is going to be a dashed line. Dashed, or sometimes we call it dotted. All right, so we got a dashed line, then greater than you shade above. So above this line is where the solution set is. Here we have a slope of 1/2, y-intercept of 1. Plot a point at 1 and then go up 1 to the right 2. This one will be a solid line because of or equal to. Less than you shade below. Here we have a slope of 1/1, y-intercept of -4. So plot a point at -4, go up 1 to the right 1. It's a solid line because of the or equal to. Greater than you shade above. We only see x, so this is going to be a vertical line, so put a point at 3 on the x-axis and then draw your vertical line. This one will be dashed. And then less than, if it's a vertical line, you can't shade above or below. So we'll shade to the left, less than, shade to the left. Think back to a number line, less than is to the left. This one we see both x and y, so it's not going to be vertical or horizontal. We have a slope of 2/1, y-intercept of 0. So put a point at the origin and then go up 2 to the right 1. Going to be a solid line because of the or equal to. Less than you shade below. Here we're going to graph a system of inequalities. So we're going to graph two different inequalities on the same grid. For the first one, we have a slope of -3/1, y-intercept of 2. So plot a point at 2 and then go down 3 to the right 1. You can also go up 3 to the left 1. This one will be a solid line. For the second one, we have a slope of 1/1, y-intercept of 2. So put a point at 2 and then go up 1 to the right 1. Now it's going to be a dashed line on this one. Now for the solid line, we're shading below. So it would be like this region, this region. For the dashed one, we're shading above. So that would be this region and this region. The region that is shaded twice is your solution set. So it's easier to show it if you just do one shading once you've determined which of the four regions would be shaded twice. First one, slope of 1/2, y-intercept of -3. Put a point at -3, go up 1 to the right 2. It's going to be a solid line because we're equal to. For the second one, we have a slope of -1/2 and a y-intercept of -1. So plot a point at -1, go down 1 to the right 2. This one will also be a solid line. Now thinking about shading, for the first one we're shading below. The second one we're shading above. So this region in here will be shaded twice. That's our solution set. All right, and in here we're just looking for the point that is a solution to the system. So graph these points. So for part A, 0, 0, not in the shaded region. 4, -2. Point B is in the shaded region, that's a solution. 0, -3, point C is not in the shaded region. And 2, -2, point D is not in the shaded region. So choice B is the only solution. I'll have another video for the rest of the review problems.